So it's been some time since I've stringed, and I still haven't figured out how to do the tags. So I'm gonna study Raylib today. I tried a bunch of different approaches, and I built a simple project to try to debug or make it easier to debug the shaders. And I'm contemplating whether or not to improve this more later on, but I just wanted to do something because one of I tried several different approaches and I wasn't getting any errors on compilation, but the text wasn't showing. So the only conclusion is that the position was probably wrong. So it was kind of annoying because I was kind of I didn't want to go over all the work of setting everything up just to check the position. But then I decided it makes more sense to just create another project and then have this template where I already have everything set up and I make sure that the positions are working and that the camera is working. And I can do something that is easier to change the coordinates of the visualization by moving the camera, because that way it makes it easier to know if it's a problem with the position or not when creating new meshes or stuff like that. So I did this project here. And then I tried other approaches to do the tags, but they were not working, and I was trying to debug with this thing here. And the last one that I was trying to do is with the Raylib. So I'm getting one of the examples that they have to render tags using distance fields. And I set up everything with the stuff that I have on the other project. And again, I'm not getting any errors on the compilation, but it's not showing anything. So, and based on the output of the render doc thing, it seems the only thing that it makes sense that is the problem is the coordinates, but I'm not really sure. I don't understand why it's not showing anything. So I'm putting the values at 0 there, so it should be showing the tags in the middle. And I set up the events based on the Raylib functionality. So I think I'm going to explain this project a little bit before I start going over. I was trying to set up the debugger as well on VS Code, but it's too annoying, so I'm just going to do it with Visual Studio, and I already did a little bit yesterday. I'm going to step over this Raylib example and then try to see how they do it, the functions, because the main thing that I changed from the way that they do it and the way that I'm trying to do there is the rendering cycle. They use a batch rendering system, and I want to transfer everything to a class so I can incorporate on the other project. But now I'm contemplating, like, if I spend too much time on this, then it's probably just easier to just straight up copy everything that they do here and then incorporate that as a library on the other project. But I'm trying to avoid doing that because I'd want to try to make it as simple as possible, the compilation. And one of the ways you can render tags is by using a library called FreeType. So to render tags is pretty much you read a file that has the information of the characters, and then from that information you create an image atlas, which is an image that contains all the characters. And then based on that, you get the information from that image to which character you want to render. And then from that image, you call some OpenGL functions and you create the image of just that character. So FreeType is used, I think it's the most used to extract information from the file and then build the OpenGL stuff. But it adds a bunch of complexity on CMake. I can add using add subdirectory, but I want to avoid using a lot of external libraries. So Raylib uses STB TrueType, which is another library that it does a similar thing to FreeType, but it's more simple and it's just one header file. And based on the example, I think is good enough. So I think that for now, I'm going to try to do it the way that they are doing here. The main difference is the shaders that they're using and the batch rendering thing. So that's what I'm trying to understand, because to be honest, I didn't like that much the way that they render. It's kind of confusing to me, but I think that they do it like that because of the overall system that they have. But for my case, it's probably better to try to simplify. Then obviously, I'm not really sure if I'm going to spend the time doing that or not. Let me put some, I think I'm gonna spend 2 hours here. Also, there's this image here that I found that's very nice. The documentation is actually very good, and there is another thing. Maybe I think I'm gonna try to see because I found some useful resources that explain better. The main thing that is I found hard to find is which now I know the name is UV coordinates, is the coordinates of the tax. So the relationship between the gel position and the coordinates of the tax. But now it's more clear on my mind how it works. So as far as I understand now, maybe I'm wrong, but I think that's how it works. You have an image that, when you render text, you create one image that is going to contain all the characters, which is going to be this image here. And then what you're actually doing with the UV coordinates and with the sampling function inside of the shader code. See if I can find the. This one is SDF, but I did this function here. So the way that this sampler works is just you can think it as if it's getting the placeholder with the information of the image. So the sampler is the image itself, this image here. And then the second argument you pass to this texture here is going to be the coordinates inside of the image itself. So the way that it works is that the positions here are the gel positions. And then based on that function, what OpenGL is going to do is just going to get whatever coordinates you pass to extract the information from the image that you currently have binded on the shader based on that sampler 2D variable. So you use an OpenGL function to determine that variable, the sampler 2D, is going to be associated with the image location that you want to pass the information for, which is usually going to be 0. So it's kind of like attribute locations. So you bind the image 0, and then you call some OpenGL functions that are going to pass the data for that image. So it's like putting data on a buffer that represents what the image is going to be. And then based on the texture function inside of the shader, you get the location of the image that you want to render. And then the gel positions are the locations where the thing is going to be rendered. So it's just replacing whatever you extract from the image into the locations that you pass on the gel position. What I still don't understand very well is if there is a correlation with the image format or not. I think there isn't, and the reason why I was getting a mistake on a previous attempt that I was trying to do is because of something else. But I think that there might be a correlation because the colors is just float variables and just math as well. So there might be. This part is still kind of confused, but I think that there might be a correlation between them. So yeah, this thing here, I didn't understand very well. I understood, but in relationship to everything else, it's still a little bit confusing. Especially this swizzling here, which has to do with the color channels. But these articles here are very good, and there's other ones. I'm gonna. So another thing that I'm not really sure, I made the events happen, but not really sure if they are correct or not. I think that they're probably off a little bit, but I'm not gonna focus on that. I'm just gonna make it work. It is working because the challenge that I had was it's one thing to zoom. There's two different ways to zoom on OpenGL a 3D visualization. One way is to change the field of view, which is the angle of the camera, and when you do that, then it gives the illusion that you're getting closer or further away. And the other way is by actually moving the camera, which is just doing multiplications of the camera matrix so that it shifts everything based on whatever you are doing with the matrix. And I think that's the way that I thought is probably better. But the issue is that if you just change the Z direction, then obviously it's just going to zoom overall, like without taking the mouse into consideration. And that's not what I wanted. And I think usually that's not what you want. What you want is to zoom in the location of the mouse. So because of that, you have to not only have to change the Z, but you have to translate based on the position of the mouse. But then I couldn't find the translations very well because the way that the Raylib does is different than the way that I'm doing. So because I'm using the other class for a camera, I think I am doing everything correctly, but for some reason it seems very a little bit off the way that it's translating. But I think I can change that based on the variable. But I'm gonna show there stuff that I'm doing or that I did. Oh, also I went to the Scratch Pixel Discord. They have Discord now, and yeah, I asked a question. It seems like they are gonna do articles explaining the events. So yeah, obviously I recommend their articles. I think that they are probably one of the best resources that I found to learn everything, because it's kind of hard to find resources that talk about the fundamental principles and not the more I learned, the less I went to see videos about how to call a function from an API, for example, and more about the mathematics and the stuff behind, like the first principles behind how everything works. Oh, and there is a software that does the stuff that I'm trying to do with this other project, which is Material Maker. And there's other variations as well with Unreal Engine and Unity. There's like far more complex that helps you create shaders and stuff like that. But the reason why I want to do it from scratch is just to learn and to have more control over the stuff that I'm thinking about trying to do. I think I found the... So one of these articles here has a link, I think, to these other ones. This is the software Material Maker. I think I have here. But these articles here, I thought that they were very good. And then obviously Scratch Pixel as well. But I think that they still don't have. It's gonna take some time, obviously, to create these ones here. This is just one that talks about shaders, Material Maker. I don't remember if I think this is another book that I found on the other sites. And then this one is very good as well. Just like this one, I think. But the way that I did here, so the way that the Raylib does it is to... Oh yeah, in sign distance field, it's not that complicated. The only thing that is happening is that you're calculating a distance from the point you send, and then based on the distance, you select the strength of the color, let's say. So I have this, that is the partial derivative, I think, of this number, which is going to be the thing that I just explained from the texture. So you're getting an image, then you're getting the coordinates of the image, so extracting the parts of the texture that you have that you want to show. And this is going to be the value that you get here. Then you get the partial derivative of both of them, which is going to be, and then the length. You're going to pass the distance to this length function that is going to calculate the strength of the color in relationship to the point you're sending. And I think that this move snap does that, actually. This calculates the length, and then this move snap calculates how strong it has to be based on the distance of the center of this thing here, I think. And then based on that, you create a color. Is this example here that I'm trying to do? So this is the default fonts, and this is the sign distance field. So I think that they use this one, and they use a very basic shader. Based on the outputs that I was getting here, I think that's what I was gonna say. I think that the problem that I have there is the position. So when I go here and I click here, you can see that the GL position is around -1, and it seems like it is creating the text, and also the texture is working based on the way that I did there. But for some weird reason, the position is like this position here, and I think that the fact the position is this is making it not show on the visualization. But I'm not really sure. And this is kind of the thing that is frustrating about OpenGL, and it is the thing that it makes it very hard, is when you get these errors, because it's actually very hard to know what exactly could be going wrong. Also because I think that it's just complex as well to render text. It's deceivingly complex. Because I spent some time looking at the functions from the libraries, but it's still very, I don't know very well how the nuances work of the functions. And it's very annoying to... I'm gonna explain some stuff before, and then I'm gonna get to the actual problem that I think I have there. The thing that I think is wrong now, actually I thought that is wrong, but now I changed my mind. I don't think that that's the problem anymore. Something to do with the position, but I'm not really sure what it is. And if I change this text here, I did with another library called GL text. It's very easy. So, to render text using libraries is not very hard, but it's actually very easy. But to understand what is going on, which is obviously I want to understand, then it's very hard. So even if I translate here everything, it should be changing the GL position here, but I think it's not. It's around the same. Which is kind of weird. I don't understand why. So it's still around the same numbers here. So this is the thing that I don't understand very well. The way that I'm doing this. So before, let me compile again, because I did the example. I took some code from the simple example there from Learn OpenGL tutorial to render a triangle, and that's how I was testing the movement of everything. Then I'm doing the text pretty much the same way, just extracting all the functions. I went through the flow of execution from Raylib, and then I just got all the functions and then translated them into a class. And then the main part that is different is both the creation of the buffers and the rendering cycle. So that's the thing that I thought it might be wrong, because it seems that they are using GL draw elements with an index buffer. The way that the GL draw elements work is that you have a bunch of vertices that are related to the points, and then you get the information from you can create another data structure that has the indices, which is unsigned integers that represent the order of the points that you want. So obviously in 3D it's going to be 3 floats is 1 index. So the array you're going to pass to create the index buffer is just the array of the indices that represents the points you have on the other buffer, which is related to the actual information of the points. And then there is OpenGL can draw, or I think that, not sure if it's specifically for OpenGL, but you can either draw the points on the counterclockwise or clockwise. And I think OpenGL, by default, it does counterclockwise, but then you can call some function that changes the order. Which is just the order you're because you're sending one point at a time. So just gonna draw everything either. So the order doesn't matter that much as long as you are consistent in the way you pass the indices. So the advantage of doing the indices is that you simplify, obviously, because some triangles are gonna have the same points. So because they have the same indices, the points are the same value, you can send the same indices to them. And I think that's the batch rendering system that they use is using that using indices to render, and I was using the raw data because I thought it is easier to get the raw data and to figure out the other stuff. And I thought that this might be the problem, because then it has to be something related to the position. I think either the texture coordinates or the GL position. But since it's creating the texture. But actually, it could be the texture coordinates as well, but I think it's less likely. It's more likely that is the GL position. And I'm doing the GL position based on... I just changed the way that they do it is that they call an OpenGL function that draws the point. As far as I understand now, I didn't like the documentation very much for these functions, but the way that I understand is that instead of creating the array with the floats of the positions, they call an OpenGL function that accepts the 3 floats and automatically draws. I thought that was the case initially because of the way that I was navigating through the project using F12 on VS Code that goes to the function definition, but I think that the place it was getting me to is wrong, because there are two different definitions of the function there. So initially I thought they were drawing everything one by one, but now I think that they are building the float. I'm gonna show there when I go over the thing. But the only thing that I did was to replace the way that they are building the points. So on this function here, I think, this draw texture pro, that's the one that they use to create. So as far as I understand, they have a source. I don't understand very well the source and the destination, but I think that it's just the source is the rectangle that has the character information from the image, and the destination is where the thing is going to be, I think, on the visualization, but I'm not really sure. But pretty much they get the positions here, and then instead of placing to a vector, they call these other functions, which now I think that it puts in a vector as well inside of a struct. And then later on they have a, and this is the part that's kind of confusing, because they render everything based on memory and based on the batch limit that they have. So it's not very clear at what point the thing is going to flush and then start rendering. But I think it's kind of the same logic. So they put everything into a float, and then inside of the rendering cycle, they create the buffers, and then later they call GL draw elements, I think. I'm not 100% sure, but I think that's how it works. So when they call GL draw elements, that's the point of confusion, because I couldn't find the place that they are building the indices. They just call GL buffer data or something like that creates the buffer for the indices, but I couldn't figure out where do they send the data from the indices. So now I'm thinking is more on the beginning of the cycle where they allocate memory for everything, but it is very confusing. So and then on that cycle they loop, and then they call GL draw elements, passing or creating the count based on the stuff that they built here. But the way that I'm doing now is pretty much I'm just pushing the positions of each one, which are going to be calculated based on this stuff here that has the information. Yeah, I think that it comes from the file already here. So it's basically just drawing a bunch of rectangles based on two different triangles each time. And each rectangle obviously is going to contain the information for the character. So you're just building one rectangle at a time. And for that reason, you do the count based on the rectangles. So they multiply by 6 and divide by 4. So multiplication by 6 because 6 points, 2 triangles, and then divide by 4 to get the amount of quads that they are sending. So first the positions, they do it on the other way, but I thought it's better to do this way because initially I was separating two different buffers as well, but now I was doing in one buffer, but now I'm separating in two because they separate in two different buffers. So instead of interpolating the values on one buffer, just creating two. This was one of the points of confusion that I had. I still kind of have this confusion, but I think now it's more clear. So the confusion that I had is if you build a bunch of buffers and then you call GL draw arrays or GL draw elements, how does OpenGL know which buffer to use? So for example, you have, because if you're gonna build the indices, then how does OpenGL know at what point should, like you have one array to determine the indices, but then you have two different arrays, one that determines the vertex position and one that determines the text coordinate. So how does OpenGL does the equivalence for one placing the indices vector? What does that value represents in the two or more other buffers that it has? But I think that the way that it does that is that you have to do them on the same length, let's say. So they can have different values. The texture coordinate could be 2 floats, and the vertex should be 3. If you're doing a 2D image on a 3D visualization. But as long as they have the same count, then the indices are going to be the same, because it's for one index is just getting the equivalent on the two different buffers or more based on the way that you set up the buffers before, which is I think this function here. So based on the way that you set up here, you're gonna indicate the size for two of them and then pass the data. So because it has the size and the amount, as long as the count is the same, then it doesn't matter, and each value on the index is just gonna be, it's gonna figure out based on the count for each one what value to use for that iteration. And the way that it does that is based on the VAO, because the vertex array object allows you to store the state inside of this. So after you call vertex array object and you create these VBOs, which is vertex buffer objects, it's gonna put everything inside of that VAO. So it's kind of like putting everything into a box, and then from that point on, it's just gonna use the same box always. So it has the state on inside of the VAO, and then based on that state, when you call the GL draw elements, you have to bind to the vertex array object first, and then OpenGL is gonna know, okay, so for that count on the GL draw arrays or GL draw elements, I'm gonna extract the information from the stuff that I have, from the structure that I have inside of the VAO. And the way that I built the sequence here is just by following the execution as well on Raylib, the execution of the functions. So from the way that they do it there, I think that you build the image first, and after you build the image, you build the vertices. So yeah, build the data for the vertices. I think it has to be that way. So first you parse the file and get the information from the file, and then you call OpenGL to create the image, which is going to be the atlas that is going to contain the information from the file, which is all the fonts, all the characters from the font. Then after you do that, you use that image and also use the positions you want to render the text at. Based on that, based on this function here, the draw pro. And this builds the data to specify where the text is going to be rendered. Then after you do all of that, then you build the buffers. I think that they build it. I'm pretty sure they build it on the rendering cycle, but I think it makes more sense to build outside for my case, because then you don't have to call each time. Just build once, and then you only have to rebuild if something changes. But and the part that is very confusing is this part of the image data and how it works. And so here it just reads the file. This is the font path, the absolute path to the font file. And then pass here, and it's just gonna read the file and store the information on the results there, on the data, based on this thing here, I think, yeah. So it reads the TTF file, holds the data, then passes this to this thing here, which is gonna call STB true type functions to get the information from the data of what the size, width, and all this other stuff for the character. I think I closed there was a file here that I had somewhere. I think, yeah, it's this one. So this information here. So STB just parsing the data and getting all this information for each character. And these are the functions that it's kind of annoying to know because it's kind of complex. It's not that hard, but it's annoying to do it. And I think that the code point bitmap, so the way that UTF works, there's also another article. I think I saved that one on C++ bookmarks. There is an article that they talk about, that I found from the other article that I showed, that the minimum information you have to know about UTF-8, but basically UTF-8 is not a number, I think, based on what the guy says. is more a code point, which is just like an agreement of what the character is gonna be. So it works with code points, which is just, but it's pretty much the same thing. Like I didn't find, I don't know. It's kind of like it's pretty much the same as saying that it's a number, but it's not precisely a number. It's just a count point, which is the representation of the character in some format there that they agreed, and that's UTF-8. So each character is a code point, and that's the reason why the names there are code points, bitmap, because a bitmap is just I think an easy way to think about it is just that should the it's like a matrix of the representation of the data. So code point bitmap just means that is the data representation of the character. I think it's whatever. Not gonna show. So probably this is what this is doing. And this, because Raylib is in C, they allocate this stuff instead of using vectors and other stuff like that. Yeah, so I think that this function extracts the information, puts it on this chars here, and returns that. So the glyphs is gonna be probably an array that contains the information for each character. An array of these structs here, I think. That's probably, yeah, this is the amount of code points that the font has. So just looping over all the possible code points that the font can have, and then extracting information using SDF type, putting on this array here, which is gonna be this struct. It's gonna hold the information for each character. And then later on, it's gonna use that to render everything. So it passes here, and then this builds the atlas based on the information. Glyph rectangles. Then this is from Raylib, I think, past image. And I changed a little bit because I put some of the variables inside of the class, so I changed some of the functions, but I don't think that's the problem that I have there. But here's where it's gonna call OpenGL. So I extracted the information from the file, from the SDF file. Then here it calls the OpenGL functions that I was talking about. So I think that the data is gonna be the data for the font file, which has all the characters. And then based on that, and this stuff here, bitmap I think is the levels of the image, but I don't remember this very well, but I think that's how it works. So depending on the resolution you have, you can lose information because of the details. I don't remember the nuances very well, but I think an easy way to think about it is like a pyramid. So you can create several different versions of the image that have different scales, because that way, as you zoom in or zoom out, it uses the different images to get to maintain the either maintain or prevent the decreasing accuracy of the image. It has something to do, I think, with the buffers, or I don't remember really well. The reason why. Yeah, but this is reminding me of the aliasing, aliasing problem, which is, I think, is similar. They're probably interconnected, but I don't know the specifics or the details very well. But like the reason why aliasing happens is because when you convert an analog signal to a digital signal, you're gonna lose information, because the analog is a spectrum, and the digital obviously is gonna be like, I'm not really sure, I think it's fractalized, maybe the correct word. It's like, instead of, imagine if you have a line, and you want to represent that line with points. So that's kind of the issue, is that depending on the variance of what you're trying to represent, there might be different ways to put the points together that is going to represent the same thing, and that creates the noise. And because of the noise, you have a loss of accuracy in the way we represent things. And the reason why this happens when you're drawing stuff with the GPU is because you're drawing everything with triangles. So the points are not perfect representations of where the thing is going to be, and that's the reason why you have aliasing. So you're losing the accuracy information because you're passing the data based on floating point values, but you're representing them on squares. So from triangles to squares, and then you lose the information. And I think it's probably related with MIP maps, but I don't remember really well. And then this is the main function that is going to create the image, and you're going to pass the data as a pointer here. And then here are these width and values are not the values of the character; it's just the value of the overall image. So, and this was one of the parts that was confusing to me. But as far as I understand now, and I might be wrong, but that's how I'm thinking about it now, is that this is not necessarily going to be the thing that is shown on the visualization, and that's the reason why the render doc shows something different. Because the texture that you build is not the thing that is shown on the visualization itself. You're building the texture under the hood, let's say. OpenGL builds the information. That's not necessarily what's going to be shown on the visualization. What is going to be shown on the visualization is whatever information you retrieve from the texture using the fragment shader code. So in this case, it's showing this because that's the texture the image that I'm building there, the font atlas. But that's not necessarily what's going to show on the visualization. And the width and height are the width and height of this image here. Then this stuff is just to tell OpenGL how to interpolate the values to build the image, because you're passing one texture coordinate at a time. So from the distance between the points you send is going to determine. There's different ways to do all the other stuff that OpenGL does to render. So like clipping, I think clipping, stencil, buffer, stencil task, buffer, depth tasks, and all the other tasks. So it's just determining how it's going to deal with these nuances. But I don't think it matters that much. I'm just going to copy. So I think I explained everything. So after it does everything, so it sets everything up, builds the image, gets data, and creates the buffers on the VAO. Then the final thing is to render. And this stuff I got from NanoVG. I don't think that I don't remember if Raylib has this. And then here I changed this now, but it's actually kind of interesting that's still working, even though I changed here. Yeah, but I think it doesn't matter because I'm not building. So the final thing that I was gonna do, because I was rendering with the GL draw arrays before, so I was rendering based on the data that I was building from the vertex. This is one thing that I was confused as well, which I talked about, which is if I'm not specifying anything related to the texture coordinates here, how OpenGL is going to know. But it is the stuff that I was talking about, the index before. So you just specify the count here. So it is not related to the only reason why I'm using vertex data is because the vertex data contains the information for the points that are going to be rendered. So obviously it makes sense to get the count based on that. But the way that it's going to work is that OpenGL is just going to do, based on the numbers, is just going to extract the information from the VAO. So it really, you can put anything you want here. It doesn't matter. It's just going to determine how many points it's going to draw based on the way that you structure the VAO before. And based on whatever VAO have binded at the moment. So I was doing it based on that, and then I thought that this might be the problem, but now I think it's not because of the way that the thing that I just said. So I was gonna, but I think it's still good to try to translate from this way, which uses this VO, and the other way, which is to create another buffer, which is the index buffer. And then I was creating a function that, which is this function here, that would get all the positions from the text coordinates and the vertex coordinates from the vertex data that I built before, and build all the indices from that thing. So I think that the way you do that is just by thinking about what triangles are going to have the same points. At what part the triangles are going to have the same points. And then whenever they have the same points, you just reduce, or you don't put that point. And the way you build that is going to depend on the stuff that I said before, which is the order that the thing is going to render, which I think OpenGL is counterclockwise by default, but it doesn't matter as long as you have consistency. So I think that the way you build this is by thinking about, so the way you build the index is not with the values of the position, it's just the values of the index. It's kind of like you're telling OpenGL what indices to draw first and in what order, based on the data you have on the other stuff you create on the VAO, so the vertex data and the text coordinate. So if, for example, if you put zero value on this index data here, then what OpenGL is going to do is just going to render the point that is related to the 0 value first. And that means that for this one, it's going to take 2 floats, because that's equivalent to 1 point. It's going to render those first, and it's going to take the 3 points for the vertex position. It renders one at a time, I think, but yeah. I think it renders the point. So it gets the floats and then renders 1 point at a time. So you just specify what indices you want to render. So I was gonna do that, but I think I'm not really sure what I'm gonna do. Because that's probably not the issue, it's probably something related to the position. I'm not really sure. And then here's the offset as well, if you wanna draw from a starting point, which is something that they do, but I think I'm not gonna do it, because, and this is the stuff that I didn't like that much, it's kind of confusing to understand how they do it. So actually, before I step over this, I have to explain how they initialize everything, which I think I'm also gonna do. So the way that I'm thinking about doing now on the other one, because I think it makes more sense, is to initialize GL of W with Raylib, because that's how they do it. And then they create a global struct called core. Then based on that global struct, they listen for events, or they put callback functions for the events that are going to track the inputs based on GFW. So GFW exposes some functions for you that allow you to pass callback functions that are going to be triggered every time that an event happens on GFW. So inside of these callback functions, they change the values of the structs that they have there to keep track of the mouse and the keyboard. And those are global variables, which is kind of something that I had a problem as well, but for now it seems that it's working. And the reason why I had a problem is because of the way that the global variables work on C++. You have to use this external variable. So you can declare on the C++ file, I think, the global struct that you want. And then on the other files, when you use that global variable, you put the keywords extern. And then the linker is going to figure out what the variable is. But it's getting some problems with that, and I think it did it another way, and then it fixed. So this is the function. I got it from them, and I did some verifications, but it's pretty much just initializing GFW, and then these are the functions that are going to set. I removed a bunch of things that I think I'm not going to use, but just setting all these functions here based on the window. So the key callback, the char, stuff like that. Then based on these functions, so this is for the mouse. Every time the mouse changes, it changes the, I think this, yeah, it runs on mouse move. And then they use these values here inside of the other functions to create the events. And I didn't like that much as well. I don't remember. I think that the reason why I didn't like this design very much is that it's because of the way that I'm doing there. Like, but they explained that, and which makes sense, that they didn't do it in the way that I was thinking about doing, because they like didn't want to force everyone that uses the library to do it that way, which makes sense, because like that's not the goal of Raylib. So, but for my case, I think it wasn't very good, because I was trying to make the wheel events, and the problem is when you change the value of the wheel, it's based on the condition that they put there on the example, it would just increase the value endlessly. So I changed some of these functions so that they work, so that I can use flag variables inside of the functions. I don't remember really well how I did it, but it's pretty much these functions here that are created for the wheel. So you use this function from Raylib, get the wheel. Initially this is going to be 0, I think. So if this is different than 0, then it means that the wheel was triggered. Then here I get the mouse position, and this is the part that I think is kind of fucked up from the way that I did it. But I'm not really sure how to fix this, because as far as I think, it should be correct. So basically the way that it works is that you get the mouse position. The mouse position is going to be on screen coordinates. So this is kind of the problem, because the way that I'm rendering everything is on camera coordinates. So I have to take from the screen coordinates to the camera coordinates. And the way that I found to do that is just to use the function on the vector, it's unproject. So you get this from screen coordinates, then you convert them to normalized device coordinates by doing this calculation, which is based on the width and height of the visualization of the viewport you have. Then I created this vector, and I called this function from the vector, which passes the camera. And then what this function is doing is just getting the inverse of the projection to take from the normalized device coordinates to camera coordinates, and then it multiplies by the camera, which is the inverse, obviously, than the project. So the way that I'm doing inside of the shader is the other way around. You multiply by the inverse of the camera projection, and then you multiply by the projection matrix. And that's how I'm translating inside of the shader. So to go the other way around, I thought that to call this function, but it might be a little bit off because of the way that it is there. So after you unproject this new scale, I did it based on which could be another thing that is wrong. But I just got the current position of the camera, and then I decrease. The reason why I decrease is because I think it's inverted. So if you add, it's not going to be natural when you zoom in and out, because like zooming in is usually when you roll like upwards. That makes sense, the wheel. So if you do it with a plus, it's like backwards. So you have to decrease based on the scale factor, which is an arbitrary number you put. So here I'm putting based on the wheel movement and the zoom increment, because that's how they do it on the Raylib example. So the Z I don't change, and it seems like it's not perfect, but I think it's good enough. Then after you do that, I get the direction of the camera by subtracting the position of this, the position of the mouse translated into the camera coordinates. Then you subtract by the position, so you're just getting the direction of the vector. So the camera position is the position of the visualization, and you're getting the direction of the mouse coordinates in relationship to that. Then in normalize, you get the value of the unit value of the thing. And then I just translate the camera based on that direction. And so it's like you're getting the direction from the point of the mouse into the center of the visualization. And then you're getting the unit vector of that, and then you're just shifting the camera towards the position based on the scale factor. And that makes it so it zooms to the point, the mouse coordinates, because then I update the camera position based on that. And the panning is like similar, but you just translate, obviously, the X and Y. But I think it's kind of off. One of the things that is, the reason why I think it's off is because I put arbitrary values here to change based on the thing that I felt that is correct. But the problem is if you zoom in and out and then you pan, it fucks up the amount because these are constant values. So what I'm thinking about doing is just making based on the zoom value. So here I can change the zoom value of the camera, which I think it doesn't do anything, but I can just do plus equals the scale factor, I think. And then here I can make the panning here based on the zoom factor or this zoom. And I think that if I do that, it's probably gonna be better, but I'm not really sure if it's gonna be good. And then I'm using these functions from GL tags to make the tags that are based on the position of the camera. These ones I studied the source code, but I'm not gonna explain. But it's just creating the tags. It's like very similar to everything else, obviously. Just creates the shader, the program. Then I set the tags based on the values of the camera. This camera log here is a string that has the stuff. Then I create this based on this string here. And then I just put all the other functions based on the example that they give there. And so here it seems like it is working. But the problem is when you pan, it's a little bit weird because like now it doesn't move as much the visualization as I think it should. I think it should always move at the same rate. So that the triangle should always move at the same rate at the mouse. But when you zoom in and out, it fucks up because I'm using constant values, I think. But if I put... And the way that I did that is just by like trying a bunch of different values based on the initial visualization of what it feels that is correct. So here is like pretty close to moving at the same frequency or the same distance. But after all this explanation, what I'm gonna do is just go over with the debugger on Raylib. I think I'm gonna skip all the GLFW stuff. Hopefully this works. It did work yesterday, so should work now. Maybe it's because here. Or maybe it's because I changed the executable. I never used Visual Studio. Just used yesterday. I think it's probably not working because I changed the thing. I should build again. Visual Studio is much better than Visual Studio Code for everything, I think. But the main reason why I'm not using is because I don't like depending on a specific ID, because then if you don't have the ID, it's like a handicap thing. So I prefer to understand everything from first principles. And now it seems like it is weird here. I'm not really sure what's going on. Because this project, yeah, this is a different project actually. That I just got the example. Not really sure what's going on. Did I change something? I think I'm gonna open this again. And close this. The main thing that I want to... There's two different things that I want to understand more. One is exactly what kind of vertex shader they use, which I think I already know. Is a default shader on the example that they use, which is just a simple calculation as well. Just the projection model or projection view model multiplication. And the other thing, which I think is more confusing, is understanding the batch rendering system that they have and how to translate that so I can do it on the other way. Because I didn't change the positions, but that's the main things are the positions. So understand exactly if the positions that I'm getting there are the same ones, and understand how they are getting, how they are creating the buffers and the draw calls. Yeah, the only thing that I changed on this one is to comment out the default stuff. So maybe that's something that is fucking it up there. I'll be right back. Oh, finally. I don't understand why. Maybe I should uncomment everything again to see if it's really working. And so I'm just gonna skip the stuff for building the thing, I think. I'm just gonna get through the parts. There's a bunch of loops here. They build a bunch of stuff, so. And I got you the parts. Of building the font. And this is weird. So maybe that's why it's blurry there. Because here they do this twice, one for the font file, for the default font, and another for the SDF font on the example. So I commented out the default one, so for that reason maybe it's messing up here. Because it seems that the glyphs are null or 0. Yeah. So actually what am I gonna do? So how do I stop this? Can either uncomment everything or... This might be one of the reasons why it wasn't working there. It can't be the path because I remember I just tested out with the... Just copy paste the example and test it out and it was working. So I don't think it's the path here to the thing. I'm gonna keep going for a little bit, but I'm probably gonna stop and then uncomment everything, just see if it's gonna give me a different result there. So here is skipping, because it's still showing a font there. So how's that possible? The process of loading the default shaders comes before this, I think. It happens when they initialize the window. So when they initialize the window, they have some functionality that allocates memory for a bunch of different parts of that are going to be used to build the buffers later. And they also initialize the default shaders, which are just strings, I think, on one of the functions. So here, I think it's just using the default there for the vertex shader and using the other one, the path, for the fragment. I accidentally pressed the wrong thing there. It's whatever.
The mystery of life isn't a problem to solve.
I was trying to see if I can look at the files here, but I don't want to risk closing this stuff and not being able to open again. So I'll look at that later, because I'm curious about the path here, but I think it has to be correct. And that's the stuff that I explained there before. Just getting the is using the global structs that it builds there on the beginning to get the information of the wheel, and that's gonna create the effect of the increasing or decreasing the bounds. Because they're probably using this to create the visualization instead of using these functions here. And this is the I'm not really sure why they decided to do it like this, but I didn't like that much. Maybe it's better, or I don't know, or they created the library a long time ago. Is it based on the documentation? The stuff that I've seen on the documentation is not used anymore, but it could be that I was looking at the wrong functions. But I'm gonna stop over. If it doesn't show here, then I'm just gonna look it up to show what functions I'm talking about. Just some OpenGL functions that you draw the point directly instead of using the draw calls. And yeah. So here is gonna set the shader that I built there. This is the function that I was talking about. Is the draw render batch. This is the main function that they use to render everything. And the thing that it becomes kind of confusing to understand is because like you start to keep track on your mind of all the other variables that they had there to do the control flow. Like, it makes sense, I think, the way that they did it. But it's hard to understand when you're trying to follow along the execution because you never know for sure if it's gonna call that function or not. And depending on when it calls this function, it's gonna have different amounts of data that it's gonna use to render inside of this function here. So I think that's what makes it a little bit confusing. So I think that there's definitely something wrong there. I'm probably gonna uncomment the other stuff because it shouldn't be calling this, I think. Or maybe this is for the... I don't remember, you know. I'm gonna uncomment things first to see if it solves the problem. If it doesn't, I'm just gonna copy the example again and then try to build. And this is what I mean that is kind of annoying as well, and it's one of the reasons why it's hard to understand what is going on. These functions here, there's a bunch of operations with bitwise operations with these addresses here. It's kind of hard to understand. I assume it's probably the addresses is probably related to the translation of the character into the code point. Yeah, UTF-8 code point. But it's hard to know if that's the issue that I'm getting there. It shouldn't be the issue, I think, because I just copied the functions, so it can't be something like that. It should be something to do with the position, but then it's kind of weird. The thing is that they are related, obviously, so that's the thing. So we're just gonna loop over the glyph counts with the value. Index position for any current character on font. So it's getting the current character. It's getting the index, so it finds the current character based on the index. I'm gonna step out. So based on the length of the text is looping over, then getting information for the current code point, which is probably going to be the UTF-8 representation of the current character. I think that's what the function does. Then it gets the index based on the count point and based on the font, and the font has the information. So the font is related to the image. So I think the index is going to be used to retrieve or to calculate the text coordinates, maybe. Let's see, index. Oh, it doesn't pass here. So it's using the index here. So the glyphs is the information of the current character, I think. And then this is the stuff that I was saying there in the image. So are these values. So I think the only thing that makes sense is that they are related. So the advance is probably, yeah, is this value here. So it's using the index to get the information for the current glyph, which is the current character. And then based on that, it's gonna change this other value for the next character. This is kind of like a pointer where you're drawing stuff, and then based on the information you go to the next one. But it's not using on this one. Yeah, but it uses the offset here, so it does use indirectly. Yeah, so I assume that this is this is gonna be the initial position there you pass. So like is the absolute position where you wanna draw the text. So it might be, but I don't see how, because currently now I'm passing 0 there on the example that I have, just to test. So the baseline should be 0 on the visualization. That's what I don't understand. So this should be 0, and then the offset should be just the information from the character, which I didn't change. So that's why it's kind of weird. The same functions, just gonna get the index again. It is kind of weird as well. I think they do it like this because probably, obviously they're doing a bunch of other stuff on the framework, so I think it might make sense to put this inside of the function because some other functions might call this one and then the other functions don't use this. But I think I'm gonna change this probably because it's calling the same function twice, so it makes more sense to pass the index to this function. One thing that I actually realized this long time ago is that the main thing, like the main fundamental principles of programming is just going to be loops, if-else statements, and then scopes, and the size of the function. So there is this thing that I think some person talked about some time ago, that the way that they recommend, the way that NASA recommends to do it is to specify as much as possible. You need to have as many functions as possible to like make the code cleaner, let's say. So each different thing you want to do, you should put on a separate function, and because that's gonna make it easier to understand what everything does overall, because everything is encapsulated into its own little box. But I think I kind of disagree with this. I think that the way that it works is that the size of the function and the size of the file is going to be a projection of the computational frequency of the network that is creating the code, which is human beings. But so depending on the amount of things you can hold consciously on your mind at each moment in time, which is going to be around 7, is going to be directly correlated with the size of the file you have and the size of the functions you have that are optimal for that network, because the creation of the symbols is just relevant to the synchronization mechanism of the network, because the network uses the same symbolic representation to minimize energy. So the symbols are just used to make energy more efficient, because everyone can compress information based on the synchronicity of the symbols. So the size of the function should be, I think, is directly correlated with the amount of variance you have on space and time, and the way that a network is going to parse that variance to create a symbolic representation, which is code. So, and I think that that's the thing that is going to fluctuate and that has a lot of arguments probably, because it's going to depend on the context of the situation. So the size of the function should be directly correlated with how a network perceives the variance of the complexity on a region of spacetime of what you're building. So, and that's gonna, because the thing that changes the most with the size of the function is the coupling factor, let's say, of the code. So the more things you encapsulate inside the function, you're constraining the logic to that scope, and the amount of code you have there is going to depend. Is going to depend on the fluctuation of the variance, because you're creating like a geometrical structure. And then the size of the file, I think that is only correlated with the is like a human thing, because if you think about computers, like you can draw everything on one line and the computer is going to understand. It's just it's like kind of Webpack or Babel, compresses everything in one line. So I think the size of the files is more related to how easy it is for humans to understand what is going on. And it's pretty much how everything works, I think. It's just symbols and frequency of variance. I need to... And next time that I snap over this, I need to remember what the source, because I want to clarify. I think they have something on the documentation that explains, or some points on their Discord, I saw some explanation of what the source is and the destination. I want to clarify that. But I think that what makes sense is just the destination as the position on the visualization. The source is the rectangle of the texture. I'm not really sure. I think on the next loop, it's probably. So this is the function that builds everything. Yeah, so that's what I wanted to say. See if what function is gonna call here. And so it is calling this function here. And that's the confusing part, because they're using this other struct here. So as far as I understand from a response that I got on their Discord, that they created this file, which is the rl, I think, rl.h file. Yeah, rlgel.h. And that is a batch rendering system. So they create this struct here, and then the struct is gonna manage everything, like the data that currently needs to be rendered, and the creation of the buffers and everything. So it's kind of hard because I don't know, but maybe if I just an address in memory. There's element count. Some vertex buffer. Oh, so I think that the reason, so element count, at least like makes sense intuitively. That's the amount of stuff that you have to render. But I think that this is just this number because of the function that they call there initially to set up the memory for the buffer, for all the buffers. So I think that this is the max memory that they set, or the beginning, something like that. And then here it doesn't have any data on this because I didn't add anything to the thing. It's kind of confusing though. And they use these four different VBOs. So this fourth one here, the third index, is the one that holds the index data, the index buffer. I think the one, either 1 or 0, I think it's the 1 that holds the vertex data, the vertex position data, and the 2 index is the one that holds the texture coordinates. But this isn't the function that renders everything. It's just I think this is one of them that calls. So it's gonna call the draw render batch, something like that here. But it only calls based on the condition there. So if you have something to render, then it calls this. I'm not really sure if it does call here. I think what this is doing is just setting the mode here to be RL quads, and the mode is going to be used inside of the rendering cycle to determine what kind of OpenGL function is going to use to draw. Normals, I don't understand very well, like what's the point of them. As far as I understand, what they do is hold information to get the plane that is perpendicular to the surface of the current point, or something like that. But I don't understand why. I remember seeing some stuff about it, but I forgot why exactly they are used. And this is the one that is, so they're holding the current texture coordinate on this state, and then on the vertex function that they're gonna put that inside of one of the values on that struct that I just said. It comes from this file. That holds the state for the batch rendering cycle, or batch rendering thing. Also, it does call this function here. Maybe this, yeah. So yeah, this is the problem, is that when you press F12, maybe I should open it with the. It goes to another definition, so it's going to the wrong definition when you press F12 there. That's why I think I was kind of confused at the beginning. But obviously, this makes a lot more sense. Another thing that I have to get into the habit of doing is just pressing Ctrl-Shift-P and then typing the name of the file. So usually I do, but in this case I don't know. I don't remember the name. But if I go to this one, I think I'm on the wrong thing. It's this one. So so here, if I go here, goes here, and then this one goes here. So initially I thought that it was calling this function, but I think it makes more sense that it's calling the other one. So, and this is the stuff that I was talking about, that this one I think is an OpenGL function. It's set on GLAD. And what this does is just draws a point. But I think that the documentation that I found there is not very clear, like on how it works or how you're supposed to do this. Specifies x, y, and z and w coordinates of a vertex. Not all parameters are present in all forms of the command. Specifies a pointer to an array of 2, 3, or 4 elements, blah blah blah. Commands are used within GL begin, GL end pairs to specify point line and polygon vertices. Color. But from this description, it's not very clear how it works with everything else. Like, how does this work with the buffer? And so, like, intuitively, I think that what it makes sense to me is that you're just, like, instead of creating the buffer, you're just sending one point at a time by calling these functions. But I'm not really sure if that's how it works. So, like, if you're gonna use this, then you use these other GL begin and GL end functions. And then based on that, so there are other functions there from Raylib that it's called push matrix or pop matrix. So I think the way that it works, probably under the hood on OpenGL, is that it's using a stack to do the calculations. So you push matrices inside of the stack. Then based on that, you do these operations with the buffers that do the calculations. Then once after you do everything, then you pop the matrix. So, but they were probably doing this way before, and then they changed to use these other functions that structure the buffers and everything. And OpenGL is probably doing that under the hood still, but now as a developer, you don't call this function directly. So like, I think it might be this way on Raylib, or it was this way on Raylib because that's how it worked before, but I'm not really sure about that. But it makes more sense that it's calling this function here, and what this function is gonna do is just gonna put the information on the one of the structs there that it has to for the batch rendering thing. This struct here, just saving the texture coordinates that it has there on this thing here. And these are the positions that it's got from the other function, and then the texture coordinate stuff, and then the color. But the weird thing about this is that it is not at any point it's not creating indices here, and I think it is using the gel draw elements, which the gel draw elements you're supposed to use an index buffer to render, as far as I understand, and gel draw array use the normal VVO. And then this vertex counter is the thing that they are going to use. They're going to loop, I think, over based on this to determine the amount of calls it has to do. So it's one vertex counter per point, I think. So I'm just going to step over the other ones because obviously it's going to be the same. And this one I'm curious about. So this is another thing that I don't understand very well. So after it does that, then it changes this depth. But I'm not 100% sure why. So I think it's related to the... So the way that the example works is that you're drawing a 2D image on a 3D plane. So I think that the reason why they do this is for something related to the Z position of the way that the image is going to be, or something related to something that OpenGL does. I think OpenGL does depth tasks. You just show tasks which object is in front of each other after it goes through the whole rendering pipeline. It's gonna probably one algorithm that just goes over the pixels and then tasks to see if there's an element being drawn on the pixel and which element has the lower Z index, I think. Then based on that, it overlaps the stuff. So it's probably related to this, but I'm not really sure. Like why, and it is always increasing by this, so I don't understand very well. So I think this is the point fonts. That's the first one. So I guess the text from here, pointer. Probably what this function is doing is just getting the UTF value based on the text. And this one gets the index. So this is the one that I wanted to show. So first argument is the font. Second argument is the UTF-8 representation of the character, I think. It's the code points of the character. For 100. I'm probably gonna step over the debugger on the project that I'm doing there after, so I can compare the two. But I wanna make sure that I have very clear on my mind exactly what is going on. So maybe I should write down these positions here, because I think that the highest chance, the thing that has the highest chance of being wrong is the positions. Something with the way that I'm doing the position there, probably the way that I'm setting up the camera, but the thing that doesn't make a lot of sense to me is that it's working when I have the triangle, and I'm doing them on the same way. So it shouldn't be something to do with the projection and the camera matrix, because if it was that, then it would there would be a problem with the triangle as well. So it's really weird that it's not showing anything. So and it's kind of hard to know exactly what is going on. So I think it's probably a good idea to just write this down here, and then once I step over the other one, I can see if they're wrong. Probably, what I'm trying to do, what I'm going to do first is to step over a bunch of times on this one and clarify a lot on my mind what's going on. Then I'm going to step over on my version of the things and try to see, like on my mind. I don't think I'm going to spend a bunch of time doing the control flow graph and stuff like that, because it's going to take too much time. But on my mind, I'm going to try to do the like overlap them and then do the difference in my mind. And if I can't figure out based on that, then probably what I'm going to do is just write down all the functions that are executed here as a step over, and then just copy paste all the functions on a file, and then try to like just do one header file and one C++ file with all the functions, and just try to call all of them, probably on another project or the other. I'm probably going to change the project that I'm creating here to test shaders. So this one, and just add another C++ and HPP file. Then just put all the functions, and then don't use a class, just use the functions directly, and see if I can render them with that. Then I think if that works, then I'm probably going to translate them onto the other project, and then or maybe I will spend some time more trying to translate them into a class, but it's more about how much time to spend, because I already spent a lot more time than I thought on this stuff. It's good though, because I had to, I didn't spend too much time on textures in the beginning, so I knew that at some point I had to improve my understanding. So this is forcing me to understand textures better. So, but I definitely feel that my understanding now is a lot better than it was before. I think I have to step into all these functions, because I want to see if it's going to call the render batch at any point here. I think these ones are not related. The only one I think is the RL begin that maybe calls the render function. I'm gonna step over. I'm just gonna do the same thing for all of them. Maybe I have to. Another thing I can do is just obviously decrease the size of the text there. I think right now I'm putting all the alphabet. I know this is the example, but on the other project I'm putting all the alphabet characters, just to see if it's gonna work. Eventually, I think I'm gonna probably have to do it with free type as well, because like what makes text even more complicated is that for the base characters is relatively easier because of the way that you get the information. But for more complicated characters, I think especially Arabic or something like that, or Chinese characters, then it becomes a lot harder because of the way that you build the information to represent the character. So the way that it works is that you create, forgot the name of the, it's a type of curve that I forgot. Bezier curves, yeah, Bezier curves. So you draw everything based on Bezier curves, which you use Bezier curves to draw the tags, not to draw the tags, but to build the information for the tags. That's how the files are created, I think. So depending on how complex the character is, there's more information you need to know in order to be able to draw, because it's like the step you have, the distance you have between characters, and the baseline of the character, and all the other stuff like that. So because of that, it makes a lot harder to draw these types of characters. And I think that free type is probably the best one that exists now to draw like a bunch of different characters. But I think I can get by. I'm gonna try to get by with this for a long time. Because my biggest concern is because of the thing that I'm trying to do. Like I'm probably gonna have to render some tricky characters at some point, because I'm gonna render stuff based on code. So, but probably, hopefully not. So, yeah, I prefer. I think it's better to just wait and see if I'm gonna have to, and then if I have to, then I'll spend time, because there's a bunch of other stuff to figure out as well. So. Another thing you can do is just open the file and then put a breakpoint to the function that I'm thinking about, so I don't have to step over one by one. And maybe it makes more sense to do that now. Nice control F. Don't remember exactly the name of there's a variation of this. How do I go to the next one? Yeah, is this render batch here? I'm gonna put a breakpoint here. So this is the function that I was talking about. I think off stream I'm gonna go one by one, but I think here I'm probably gonna just continue and see if I can get to this function here. Because this is the main function as far as I understand that is gonna draw everything. So after you loop over that, build everything based on the information, then here is gonna create the buffers. But the thing that is weird is that it's not creating the buffer for the indices. So as far as I understand now, the vertex count is gonna be more than one because it increases there on that function that has the same name of this one. This function here is gonna increase the vertex count here. So it's just based on the points. Then based on this, it's gonna create the VAO here, and then it's gonna create the buffers for each one. So it sends the data. So it holds the data for the vertices on this structure here. And this creates it's just creating the data that OpenGL is gonna use from the buffer. It's just sending the data to the buffer. So the size is 3 floats, and then sends the data for the position based on this. And I think this is the struct that uses there. Sure, it has to be. So it's kind of confusing because it's a different name here because it's getting from the argument here, but I think it's the same. Vertex buffer, batch buffer. Yeah, vertex buffer, current buffer. Yeah, so it stores the information here as it builds the quads for the tags. And then here is gonna send the other information. It's gonna create the buffer here. So yeah, the 0 position is the one that has the vertex position. The one has texture coordinates. This has the color, and then the other one, I think it has the, not sure if it's here or later, but it has the indices position or indices data. I'm pretty sure it's supposed to be here. Hmm. Oh, I think, yeah, it's here. So I'm not really sure what the eye is supposed to be, but I think it's if you have more than one camera. So they allow you to have more than one camera, so it's looping over all of them. But I'm not really sure, because it doesn't matter for me. Oh, that's the part that is weird. So they're just building the matrix here, the MVP. So I think they store everything on one matrix, and then they send the final matrix to the shader. And then here, they are binding the... And this is the part that is weird, I think. So like here, they send the data to these 3 different buffers. And then here they are binding the buffers with the data. But the thing is, they are binding this 3rd buffer here, which is supposed to be the index buffer, but they didn't send any data there. So that's the thing that is confusing. So what is going on? And then here is just the function that is gonna specify how OpenGL should read the vector of floats to build the points. So they're building different buffers. You can also interpolate the data on one vector and then just change the specification on here, how to read. But they do it separately. I think this is just gonna activate the images, the current image, and then bind the image. And then here, based on this offset and the draw counter, I think that the draw counter stores... This is another thing that I'm not 100% sure. But maybe is like each draw counter is one whole thing that you wanna draw. So the vertex count is how many points, but the draw counter is how many geometries, I think. But I'm not really sure. Yeah, but what is happening is just looping over this, and then it's gonna call... I think it calls this one. And this is the part that is confusing. So it's getting... So this is the calculation that I was talking about. So it has the vertex count, which is the amount of points. So it multiplies by 6 because it's 2 different triangles should do a rectangle. And then divides by 4 because it's how many rectangles you have. So I think it is the stuff that I was talking about. So like the draw count is gonna... is equivalent to the whole text, I think. So yeah, and it is like this because maybe you want to draw other stuff. So, and they do, they render everything through this system here. So let's say you have a text and a circle, for example, then the text would be one draw count, the circle would be another one. And then here is just the amount of quads that it has on the inside of that struct. And here is the offset, which is where it should start on the vector that contains the information for the indices. So I guess that's the question, is at what point do they send the data to build the indices? And the reason why I think is using this one is because of the mode there, that is set to RL quads. So it should follow here, I think, on this function. Yeah, it's weird that it's not stopping there. Huh. So on this one, goes here. Trying to see if I can find the maybe if I after I step over the thing, can find the information of the indices. And the question is, how do I know? How do I know where the data could be? I think just based on the other ones. And so it should be here. So batch, vertex buffer, and then batch currents. So batch, vertex buffer. Oh, indices. There should be this thing here. But it's saying it's 0. I think the value is 0 and the location in memory is this. Yeah, it should be that because this one has the... Yeah, so it's supposed to be 0, but then it doesn't make any sense. So it is the way that I was thinking about there. So the draw counter is how many things you're gonna draw in general. So this is related to like all the data of everything. So yeah, it makes sense. So the offset is gonna be 0 here, I think. On my case there. But I still don't understand where are they putting the data for the indices. Because as far as I understand, OpenGL requires you to have a inside of the VAO. You should have a buffer, or you need to have a buffer that is going to represent the data for the indices, and then based on that buffer, is going to do the draw calls. It's going to get the points and the whatever information it needs are going to be based. So the way that I think is working is just like is looping over the index buffer. That it's going to contain the indices, obviously. So it gets the index, and then it just uses the index to find the information on the other buffers of where the points are at. And then based on the size of each point, it just gets the values for each one. So if you have index 0, it's just going to go from the 0 index on the other buffers you have. And then it's just going to get the floats that are equivalent to the size of the thing, which depends on the way that you structure the GL attribute vertex information. So, but if that's how it works, then I don't understand how is it possible that they, like, at what point they are creating the data for the indices. I think that the only thing that makes sense to me is that it's happening on the function that I said before. In the beginning, they have a function that they allocate memory for each thing, for this structs that they are using. So they could be creating the indices on that function. But then, like, how is that possible? Because the indices should depend on whatever you're gonna draw. So It doesn't make a lot of sense to me. This is another thing that is kind of confusing because there was only one value there. So maybe it's rendering 1 point at a time, one character at a time. But then it wouldn't make sense. I think this is just zeroing everything out. After it renders everything, it just puts everything on the default state. Yeah, now it's just GLW functions. So let me see. It's not 2 hours yet. I think I'm gonna stop here, and it's probably gonna take a long ass time. So what I'm thinking about doing is just going over the beginning, and then I'm gonna step over all the. Or maybe I'll find manually the function where it allocates the data, and then try to see. So first I'm gonna step over that, then I'm going to go over the other project and debug the other project, the one that I'm trying to make it work. Just see if there's. I think also what I'm gonna do is just write down the values probably. So as I step over this, I write down all the values here that I think are relevant. Then as I step over the other one, I'm gonna compare to see what is the difference. But I'm gonna stop now. I'm gonna continue to do this off stream. So I'm not sure when I'm gonna come back. But I'm gonna continue to do this stuff here. If it takes too much more time to do the text with the class there, I'm just gonna get it from Raylib and then incorporate on the other project as a library. But just the functions that are related to this sign distance field text, and then I can put on a, or can just call the function, create a class that just calls the functions, then make that class inherit from object 3D, and then make the position of where the text is going to be rendered based on the position of the object 3D class. And then if I do that, then I'm able to do the position of the label relative to the position of the sphere. I think that it shouldn't be very hard, but I want to make sure that I understand this, so I'm probably going to spend a lot more time just making very clear on my mind how everything works. Then once I figure that out, then I can continue to do the other stuff, which is just the physics and everything else that I have to do. So yeah, see you next time.